Welcome to Decoding Computer Studies, the Master Blueprint, a visual synthesis of computing fundamentals, from silicon cores to global networks. Computing is structured as 6 interdependent layers, moving from microscopic processing to macroscopic impact. We will explore each layer in this video. Layer 1 is the core. The central processing unit, or CPU, coordinates logic and arithmetic using dedicated buses. These buses include the data bus, address bus, and control bus, which manage information flow between the CPU and primary storage. Storage architecture balances processing speed against data permanence. This hierarchy includes fast, volatile RAM and registers to slower, permanent secondary storage like hard disks. Data structures scale from a single bit to complex files. The machine translates all human input into discrete mathematical states. This involves converting data into pure binary and various coding systems, like binary coded decimal, octal, hexadecimal, and character codes like ASCII. Layer 2 is the control. The operating system acts as the master traffic controller, managing essential functions. These functions include job scheduling, memory management, interrupt handling, and I/O management. The software spectrum bridges machine architecture with user intent. Software is divided into system software for machine operations and application software for user tasks. Translators like assemblers, compilers, and interpreters convert source code into machine code. Layer 3 is the logic. System development is an iterative cycle of engineering and implementation. The cycle includes stages from problem definition and feasibility study to system design, programming, implementation, and maintenance. Implementation involves various changeover strategies. Logic scales from visual algorithms to structured code. We see this progression from flowcharts to pseudocode, and finally to high-level programming code. Layer 4 is the application. Databases structure raw data into relational, normalized intelligence. Data integrity is crucial and maintained by preventing errors like transcription and transposition, using normalization and primary keys. Spreadsheets empower automated recalculation and what-if analysis. Key concepts include the fundamental cell, distinctions between labels and values, and the use of relative versus absolute referencing in formulas. Layer 5 is the connected. Network topologies define the physical routing and fault tolerance of a system. Common topologies include star, bus, ring, and mesh, each with unique advantages and vulnerabilities. The physical arteries of communication enable the global web. These include twisted pair, coaxial, and fiber optic cables. A local area network connects to the wide area network, which is the physical infrastructure known as the Internet. Layer 6 is the human. Security requires a defense in-depth approach against human and digital threats. Defense mechanisms must address threats ranging from viruses and unauthorized access to hardware failure and physical damage. Technology ultimately reshapes human biology, labor, and society. Ergonomics focuses on the individual's comfort and safety. Labor and commerce are affected by automation and the shift toward telenetworking. The master blueprint of computing is about building systems that elevate human potential.